So question 32 of your exam hopefully looked familiar, because that was exactly what you did in the practical. And actually I was cheeky enough to use exactly the stuff that you did in the practical. So here is basically the instruction, and you set up your standard curve here. And the first question basically is to calculate how much BSA, the amount of BSA that is in each test tube. And so the first value is pretty trivial. We don't have any BSA in it, so the number would be 0. We have no BSA in it. So in the second tube, we have 0.1 milliliter, and our solution had 10 milligram per milliliter. So we want to know how many milligrams we have, and we can do that with the dimensional analysis. So we are looking for milligrams, so we have 10 milligram per milliliter. Milligram is good, but we want to cancel the milliliter, so we have to take it times 0.1 milliliter. The milliliter cancel out, and we have 10 milligrams times 0.1, and that gives us 1. And so for 0.2, we have 2, we have 3 milligram in test tube 4, we have 4 milligrams in 5, we have 5 here, we have 7 here, and we have 10 milligram of BSA in the in test tube A. So that was basically what I was looking for, these numbers here. Now, and here is again properly written down. So the next question in B, you were supposed to construct a standard curve or on the supplied graph paper, and if you did that, you would get something like that. So important was that you correctly labeled BSA in milligram and your absorbance. Please note there are no units here on the absorbance. You did not get any marks if you, instead of BSA here, you did the tube number. So 1, 2, 3, 4, and so on. If these were the tube numbers, then this was definitely not correct, and I didn't give you any marks. And it should give you a really nice, proper straight line. You had to label all the axes properly, and you had to present a nice straight graph for that. Okay, then in the next question you were supposed to find the correct, the corresponding amount of BSA from the absorbance using the standard graph. So you had an absorbance of 0.14, 0.15, 0.16, and so all you need to do was really find, and I can't do that nicely here, but it should have been something like this here. And this should have given you something along the line of the milligram of proteins here, 4.67, 5 and 5.33 milligram of protein that you should have got from your graph. Now the next step was basically to convert that into a concentration here. And all you needed to say was, okay, I had, for example, if I take this middle value, I had 5 milligram, and these 5 milligrams were brought in from here, where we used 0.2 milliliter of a total of 1. So we had 5 milligram in 0.2 milliliter. So therefore we could say we had 5 milligrams in 0.2 milliliter, and therefore the concentration would have been 5 divided by 0.2, that would be 25 milligram per milliliter of our standard solution. And you could have done this with this one and this one as well. And if you did that, you would have got these numbers here. Now, I expected you to actually do this conversion simply because we have also done that in the practical. So in the next step, you were asked to do a little bit of statistics and calculate the mean, and most of you did that all right. So here the mean to calculate that would be you just add this together and divide by 3, so that would be your mean. Your population variance, okay, so your mean would be about 25 milligram per milliliter. That's this one here. And the population variance now, what you needed to do was really you need to take 23.33 minus 25 squared plus 25 minus 25 squared plus 26.65 squared. Sorry, I need to minus 25 squared, and then because we've got a population, we divide by the number of observations that we have, so it would be 3 here. And if you'd done that, you would get roughly 1.84. Now for the population standard deviation, you would just simply take the square root of this whole thing, and you would get 1.36. And for the standard error of the mean, so the SEM really is you take the population standard deviation and divide it by the square root of your observations, so divided by square root 3, and you should get something like this. Now in question F you are asked what does this R value, and I think the R value was 0.99 or so, what does this indicate? Well, it indicates that it is a strong positive correlation. And I was really looking for these strong and positive and correlation, because this is the technical term for it. So people said that 99% of the data points are on a line, and it fits very nicely. Yeah, that's all right, but I really, you need to get used to the terminology. Now, in the last question, in question G, you were asked to calculate the extinction coefficient, and that was quite challenging. So when we go back to our original data table here, so we can, for example, take this data set here, and we can write the Beer-Lambert law. So we have absorbance equals concentration times the extinction coefficient times the path length, and that was 1 centimeter. So we have really 0.03 equals the concentration that we have. So we had Here we had 1 milligram in a total. We had 1 milligram of BSA in a total of 1 milliliter. That was our concentration. So equals 1 milligram per milliliter times epsilon times 1 centimeter. And now we just simply solve this for epsilon. Epsilon equals 0.03, that's the absorbance, over 1 centimeter times 1 milligram per milliliter. And what we get would be 0.03. Now, we would have milliliter, this goes up, the milliliters go up, times milligram to the minus 1, centimeter to the minus 1. Now I've accepted other readings depending on how you did it, but it's very important that we stick to this kind of unit, so milliliter per milligram and centimeter. So I hope this explains how you actually get to this or how you answer this question to get full marks. Thank you very much for watching.